Tonight's video is a review for our test on covalent compounds, and this will help you prepare for the test and our study session that we're going to have tomorrow. To begin with, covalent compounds are composed of two or more nonmetals. And in covalent compounds here, elements are going to share electrons to get to 8 valence electrons, the exception being hydrogen shares to get to 2 valence electrons. A couple of examples of this are we have H2O, also known as dihydrogen monoxide. An additional example would be NCl3, which would be nitrogen trichloride. When showing your work for a covalent compound, one way that we could do this is by drawing a Lewis dot structure here. So if I were to take our previous example of water, also known as dihydrogen monoxide, I would start by drawing my oxygen, which has a total of 6 valence electrons. And I would draw my hydrogen, which has its 1 valence electron. And like I said before, hydrogen is trying to get to 2, and every other nonmetal is trying to get to 8 valence electrons. And so I'm going to circle the electrons that I'm going to share. So here we have hydrogen now has its 2 valence electrons. And oxygen, if we were to look at, has 7 valence electrons. So I need to draw in another hydrogen, and it's going to share an electron to give oxygen a total of 8. When I do my Lewis dot structures, I always start with the element that's going to provide the most bonds. So let's say I wanted to create C2F6. Okay. So carbon has 4 valence electrons, and fluorine has 7 valence electrons. So carbon's able to form a lot more bonds. I'm going to start by connecting these carbons together, and then I'm going to draw in each of my fluorines here. Okay. And each fluorine is going to share 1 electron with carbon to give fluorine 8, and gives carbon another 1 to get closer to 8. Now for the other ones here, I'm not going to draw in all the electrons. I'm just going to draw the electrons that we're going to share to save some time here. But understand that there's another 6 electrons on each of these fluorines that's not being shared. So circling, like I did here, both in the water molecule and the C2F6 here, or dicarbon hexafluoride, this is one way of showing the electrons that are being shared. But the final answer that's proper is that we want to replace those circled electrons with a single line to represent each pair of electrons that's being shared. Okay. And I could do the same thing with dicarbon hexafluoride also. In addition to the single bonds that I showed in the previous example, where we're sharing 2 valence electrons, we also have what I refer to as double bonds and triple bonds. Okay, and so a single bond is just like before, sharing 2 electrons, so 1 electron each. A double bond is the sharing of a total of 4 electrons, or 2 electrons each. And then a triple bond is the sharing of a total of 6 electrons, or 3 electrons each. So the most that any atom's going to share is 3 electrons with its neighbor to give it a triple bond. Carbon, if you noticed before, has only 4 valence electrons. So it can form a mixture of single, double, and triple bonds. Now, when we go to name our covalent compounds, it's different than ionic compounds in that we need to include prefixes to indicate how many atoms of each element are involved with the compound. For the first element listed in a covalent compound name, if there's only one of them, you don't include a prefix, and you just write the element as is. If there is more than one, then you would include the prefix. The second element listed, you're going to include prefixes and change the ending to IDE. Now my prefixes, we have 1 equals mono, 2 equals di, 3 equals tri, 4 equals tetra, 5 equals penta, 6 equals hexa, 7 equals hepta, 8 equals octa, 9, nona, 10, deca. Okay. You will need to include these prefixes when naming your covalent compounds. So let's look at a couple of examples real quick. If I were to give you C3H6, this would be tricarbon hexahydride. CO2 is just carbon dioxide. There's no prefix with the carbon here because there's only one carbon listed. H2O2 is dihydrogen dioxide. Okay, you should be able to go from either the formula to the name or the name to the formula because it's telling you exactly how many atoms of each element you need to include. The last part here that I want to review here from our lab that we did is that the general physical properties of covalent compounds when we compare them to ionic compounds is that covalent compounds have a low melting point. These are going to burn relatively at low temperatures after melting, and they're also very poor conductors of electricity. So if you were to put sugar in water, it's not going to conduct electricity like sulfur or like sodium chloride would in water. That's it for our video review tonight. Make sure you watch the video. Like I said, come to class tomorrow ready to review. We have the test on Friday.